Welcome back to my channel. So let's continue discussing about heating and cooling of the atmosphere. This video will briefly cover information on the three important processes or the key mechanisms of heating and cooling of the atmosphere, which are convection, advection, and latent heat. So the information that is shared in this video will not only help in civil service exam, but it will also help in other competitive exams like banking, SSC, state civil service exams, etc. So aspirants would find this video very helpful while preparing for the IAS exam as well. So in the previous video, we discussed about the Earth's energy budget that describes the balance between incoming solar energy and outgoing energy radiated back into space. We also looked at the difference between long wave and short wave terrestrial radiation. The next key mechanism is insolation, the amount of heat that is absorbed by the Earth's surface, and the Earth's surface in fact acts as a radiating body reflecting back the heat into the atmosphere. We also discussed about conduction. So in this context of the atmosphere, conduction occurs when the air near the Earth's surface gets heated by the ground, and this heat then is transferred to the adjacent air layers. In today's video, we will discuss about convection, advection, and latent heat. Let's look at convection first. So what is convection? So as you see in this picture here, due to heating, the air in contact with the earth rises vertically. So the atmosphere's heat is transmitted through heated air in the form of currents. So convection is the term for the process of heating the atmosphere, nothing else. Okay. So the troposphere is the only place. So you know that the atmosphere is divided into various layers: stratosphere, troposphere. So troposphere is the only place where energy is transferred by convection. So the air in contact with the earth upsurges vertically on heating in the form of currents, and then it transfers the heat of the atmosphere. Now this vertical heating of the atmosphere is known as convection. So the convective transfer of energy is limited only to the troposphere. So that is what we have to understand. So here the land gets heated up quickly, air warms, it becomes less dense. So you know that when the air warms, the molecules in the air expand, and so the density of the air reduces, and this allows the air to warm up and it rises, okay, due to less density. And then as it moves upward, it comes in contact with cold temperature, and so the air cools, it becomes more dense, the density increases and sinks. Okay, so this vertical heating of the atmosphere is known as convection, and this convective transfer of energy is only limited to one layer of the atmosphere, which is the troposphere. So what is convection in detail? Convection is a heat transfer process involving in the movement of fluids. Okay, so we must understand this movement. Okay, movement of fluids, whether liquid or gases. When a fluid is heated, particles near the heat source become more energetic, expand, and become less dense, creating an ascent. Okay, it ascends. Colder and denser particles then fill the vacant space, creating a continuous flow. This process is common in the Earth's atmosphere, where convection contributes to air circulation and climate. Okay, so to give you another example, convection primarily occurs in liquids and gases because their particles can move around more freely than in solids. So let's understand about density now. So when a fluid is heated, it expands and becomes less dense. Conversely, when it cools, it becomes denser. Okay, so when it warms, the density reduces, and when it becomes cold, the density increases. So in the atmosphere, this convection plays a very important role in weather patterns. So when air near the surface rises, cools, and condenses in the sense it forms clouds, and this potentially leads to rainfall. Okay, so this is one example for convection. Another example would be mantle convection. Okay, convection that also occurs within the Earth's mantle. And this actually, so you know that the Earth's mantle, the core of the Earth is so hot. Another important factor, the core of the Earth is so hot that it is almost equivalent to, the surface of the sun. Okay, the heat is almost 5,700 degrees Celsius on the surface, and the heat, or if you have to measure the heat in degrees or in Celsius, it's almost equivalent to 3,700 degrees Celsius. It is that hot in the core. So the mantle convection is also an important example here to help you understand that convection not only occurs on the surface, rather it occurs within the earth, in the core. Okay, it occurs within the earth's mantle. So this drives the plate tectonics. So we know that the continents, they drift away from each other. Okay, they drift away at the rate of 1 inch per year. So the reason for the drifting of continents is because of the movement of tectonic plates, and this again is associated with the process of convection. So driving plate tectonics, and it also contributes to phenomena like natural disasters like earthquakes, volcanic activities, etc. Okay, so this again is a key mechanism for the heating and the cooling of the atmosphere. So moving on to the next slide. Now this talks about advection, which is again another important method or a key mechanism for heating and cooling of the atmosphere. So advection, the transfer of heat through the horizontal movement. So we understood the convection is vertical movement. Okay, transfer of heat through vertical movement. Here advection is the opposite. It is the transfer of heat through the horizontal movement of air, and this movement of the air is comparatively more significant than the vertical movement. Okay, so most of the variations in weather is caused by advection only in the middle latitudes. So during summer in tropical regions, predominantly in the northern India, local winds called Lu is the result of the advection process. Okay, so Lu winds are nothing but hot, dry winds that blow from the deserts. So this happens only during the summer season. It happens only in the tropical regions, tropical equatorial regions. And if you see, this is predominant. You can see this, you can witness this in northern India. This again is another example of advection. Now, another example of advection, to make you understand this in simple terms, is the context of warming hands. Okay, warming hands is when warm air moves over a cold surface, like a cold hand. The heat from the air is transferred to the hand, causing it to warm up. And similarly, like I told you, so this is one example. So where the heat from the air is transferred to the hand. And again, this is horizontal movement of the air, or the transfer of heat horizontally. Okay, and this causes the hand to get warmed up. Similarly, the Lu winds, if I have to compare or relate this with the Lu winds, the Lu is a hot dry wind that blows in the northern India. We know that during the summer season, right? So this carries hot air from the deserts, impacting the temperature of the region it travels over. Okay, so that's why, so this is a vertical movement of air, vertical movement of transfer of energy. So we call this as an example of the process of advection. Next important point, or the most important key mechanism here, is the latent heat of condensation. So what is latent heat of condensation? It is nothing but the energy that is released when a substance changes from a gaseous state to a liquid state. So in simpler terms, when water vapor cools, condenses into liquid, it releases heat into the surrounding environment. Okay, so condensation is the process where a substance changes from a gas to a liquid. Okay, so during condensation, what happens is the molecules of the gas slow down and they move closer together, releasing energy in the form of heat. So latent heat is nothing but the released energy is called the latent heat of condensation. Okay, it's latent because it doesn't cause a change in temperature during this phase, and instead it is used to change the state of the substance. Okay, so for example, for water vapor, the latent heat of condensation is the energy released when water vapor turns into liquid water droplets. So this process again is very crucial in weather patterns as it's associated with cloud formation and precipitation. Okay. To explain this in geographical terms, so the atmosphere receives a large percentage of its latent heat energy, and this happens through which wave? Short wave or long wave? It happens through long wave terrestrial radiation. Okay, and conduction and convection. All these are long wave terrestrial radiation. Along with them, the heating and cooling process of the atmosphere, the latent heat of evaporation, as well as the latent heat of condensation also plays a crucial role. Now, the latent heat of condensation is seen in different layers of the atmosphere, not only in one particular layer like the troposphere. It is seen in different layers, okay, where we see convection only in the troposphere, but here this is seen in different layers, and it is especially by the process of evaporation taking place at the surface. Okay, at the surface of the oceans or the humid ground or natural vegetation. So these are the major sources of evaporation. Most important source of latent heat of evaporation is definitely oceans, with their extensive water surface as they have exposure to the sun. Further, what happens is this solar energy is stored in the air in its potential form, and during the condensation of water vapor, there is release of latent energy into the atmosphere, and this is used in heating. So this released energy is known as latent heat of condensation. Okay, so we know that water is present in the atmosphere, right? It exists in three different phases: gaseous as water vapor, liquid as water droplets, and solid as ice crystals. So among these three states, water in its gaseous form acquires the highest internal energy, followed by the liquid state and then the solid state. So when any substance in the higher internal energy phase transforms to a phase having a very low energy, it is accompanied by the release of energy. So when any substance in the lower internal energy phase transforms to a phase with higher internal energy, it is accompanied by energy absorption. Okay, so you should understand this is very important. So when any substances that has a higher internal energy transforms to a lower internal energy, it is accompanied by release of energy. Simultaneously, when a higher that is lower internal energy phases transforms to a higher internal energy, it is accompanied by absorption of energy and not release. Okay, absorption. Okay, so low to high leads to energy absorption. High to low leads to release of energy. So this absorption or release of energy by the water vapor that is present in the atmosphere as it changes its phase is known as latent heat of condensation. So you should know that whether it is changing from condensation to evaporation, sorry, condensation to precipitation, or from evaporation to condensation, there is a change. There is a change from one process or one phase to another phase. What is important here is we must understand whether there is release in energy or absorption of energy. So accordingly, there is changes that we notice in the weather pattern, and this absorption or release of energy by the water vapor present in the atmosphere, which leads to changing into different phases, is known as latent heat of condensation. So with this, we've completed the explanation of the key mechanisms of heating and cooling of the atmosphere. Till we meet again, take care and thank you. I hope you find this video useful. If you have any doubts, please do write in the comments below.